All right, here we go. Lesson 5.3, we are solving systems of linear equations by elimination. This is now the third method that we've used or will be using to solve a system. So we're going to solve by systems with elimination and do some real life problems. So here are the steps. These are found on page 144 of your student journal, so there's no need to copy them down. But in step one, we want to multiply only if necessary one or both equations by a constant so that at least one pair of like terms will cancel, okay? They'll have the same or opposite coefficients. Um, then we'll add or subtract the equations accordingly and then solve the resulting equation. So this is what it looks like. So notice that we have, the x's are the same, but the y's are opposite. We have a +2 and a -2. So what we're really going to be doing is adding these. Now, when I solve these, I kind of like to just use addition all the time. But, if we wanted to look at this top one and say, oh, these two are the same, so we'll just subtract this one, right? It's kind of like multiplying it times a -1 because you would want to have take the opposite of everything. So this would become -3x, +2y, and +4, and then it's kind of like the same as adding. So that's what I would do because it gets too confusing to have to remember if you're adding or subtracting. So if you just get opposite signs, then you can always add, okay? And so what we mean by add, we would literally add the like terms. So 3x plus 3x is 6x. This +2 and -2, they cancel out, and 4 minus 4. So now we're solving for x, and we get x is equal to 0. Now we can substitute it back in. So let's give this a try. Page 145. All right, they have it set up for us nice and neat that one of the variables is already going to cancel because we have opposite signs for the x. So if we add, going straight down, add the like terms. So if you have to rearrange your equations to make sure that the like terms are, stacked on top of each other, that's fine. But x plus -x is 0. 3 plus 2 is 5y. And 17 plus 8 is 25. So elimination tends to be pretty much everybody's favorite because look how quick and easy we just solved that, as opposed to the substitution, which took forever. Now, we're not done because we want to go back in. So in the first equation, x plus 3 times this 5 is equal to 17. So x plus 15 equals 17 minus the 15, and x is equal to 2. So we have 2 comma 5 as our solution. Just quickly do some mental math to double check that it works for both. So go ahead and you solve number 2, and then I will continue with number 3. So number 3, again, the x's are set up to cancel. So we're just adding. So 3 plus a -1, it's like 3 minus 1, which is 2y, and 10 plus -2 is 8. So y is equal to 4. If y is equal to 4, we can go into either equation. We'll go into the second one. So we'll add 4 and divide by -2, and x is equal to -1. So -1 comma 4 becomes the solution to this system, and then double check it, make sure that it does work out, and we know that it does. So all right. So sometimes we need to put them in shape. So looking at this, we have, this system and nothing is canceling. But we could quickly multiply the second equation by a -2. If we multiply by a -2, right? Literally just do this, -2. So -2 times -10x is a +10x. -2 times -6y is a +12y. And -2 times 23. So this is a little different because we're actually, both sides of the equation has to get multiplied. Then you can go ahead and add and continue working. So we'll look at what that looks like in the next couple examples. So obviously I've skipped around a lot, and now we're on number 10. So if I'm going to do number 10 for you, I would look at these and I see that, oh, lots of opportunities. We can multiply the top equation by -2. We can multiply this bottom equation by -2. I'm just going to do the top one just for, all right, so that means I have to multiply this, this, and this. So I'll rewrite it down here. So we have a -2x, we have -4y, and 20 times -2 is equal to a -40. So now the two things, so the one that I multiplied, I changed, right? I'm just going to cross that out because these are the two that I'm going to add together. So my x's will cancel. -4 plus 1 is -3y, and a -40 plus 19 is a -21. So I'm dividing by -3, and I'll get y is equal to 7. And if y is equal to 7, I can go to my first equation. 2 times 7 is equal to 20. So x plus 14 is equal to 20. If I subtract 14 from both sides, I get x is equal to 6. So 6 comma 7 is my solution for this equation. So why don't you go ahead and work on this one? Lots of choices. And I will continue on to number 12. And in number 12, I'm going to choose to, let's see, maybe cancel the x's here. It's always easiest if the coefficient of one is a factor or one of them is a multiple of the other, because then you only have to multiply one. What if we had the situation like this, right? There's nothing I can multiply 4 by that would make me have a coefficient of positive 10. So sometimes you have to multiply both the equations by the least common multiple to get them to be the least common multiple of the two numbers. In this case, which would have been a 20, so I can multiply the top one by 5 and this one by 2. But I can just as easily multiply the second equation by this -3. Okay, so I'm going to get -9x, positive 30y, and a positive 6. So I like to cross off this so that I don't get confused. Now my x's will cancel. I'll have 34y is equal to 66. No, it will not be. Hold on a minute. And I believe I might have just said the word 66 when actually I'm adding these, not multiply them. That's why it confused me so much. Darn brain. All right, here we go. So now I can easily, this makes way more sense other than the fact that, I am going to get a fraction. So I have 1/2, and it's positive. All right, so y is 1/2. Let's go up here to the top equation and solve that one, because when I have to multiply by 1/2, I want something that will clear the fraction. Okay, so 9x plus 2 equals 11, subtract 2, 9x is equal to 9, divide by 9, and x is equal to 1. So I have the ordered pair, 1 comma 1/2. Yeah, fractions are never neat and easy, so just be careful. Take your time. All right. And we'll have another word problem. The sum of two numbers is 22. The difference, okay, so the two numbers are obviously going to be x and y. So if I add them together, I get 22. Let's subtract in the same order. I'm going to get 6. So now we can use elimination and my y's cancel out. So I'll have 2x is equal to, and then I add these together to get 28 and divide by 2, and I get x is equal to 14. So if x is equal to 14, right, 14 plus y equals 22, I subtract 14 from both sides, and I'll get y is equal to 8. So 14, 8 is my ordered pair that is the solution to both, and I want to double check it. Is 14 plus 8 22? Yes. Is 14 minus 8 6? Yes. And that's how you can check your work. All right. So in summary, we just want to look at all the different methods that we've used so far. Lesson 5.1 was graphing. We use it to estimate some solutions by if you have them both in slope intercept form, you can quickly put them on a graph. Um, 5.2 was substitution. That's when one of the variables in one of the equations has a coefficient of 1 or -1. We can quickly isolate one variable and substitute it in the other equation. And then elimination when at least one pair has the same or opposite signs. And then also we had to sometimes multiply one of the equations first before adding or subtracting. So that's a summary of all the methods for solving for systems of equations.